1,400 years before Newton, before Leibniz, even before the birth of classical Greece, ancient Babylonian mathematicians were using a form of calculus. Yes, calculus. And they used it to track the heavens, measure motion, and predict the future. Ancient Babylon, home to kings, astronomers, merchants, and some of the most advanced mathematicians the world had ever seen. But for centuries, the extent of their brilliance was hidden, locked away on clay tablets scattered across museums. These tablets contained cuneiform inscriptions, tiny wedge-shaped marks pressed into clay over 3,500 years ago. But these weren't simple records. The Babylonians were obsessed with the sky. They tracked Jupiter, called Marduk, with a precision unmatched until medieval Europe. Until recently, we knew they were brilliant observers. But we didn't know they were also brilliant theorists. In 2016, a discovery changed everything. Researchers found that tablet BM 454 contained something shocking. Not just arithmetic, but geometric calculations of velocity over time. And that's when historians realized the Babylonians had been using an early form of integral calculus. The Babylonians used geometry to calculate the area under a curve, and that, in modern terms, is one of the foundations of calculus. But how could a Bronze Age civilization discover something so advanced? To understand Babylonian calculus, we start with Jupiter. To them, it wasn't just a planet, it was a divine messenger. Its movement across the sky carried meaning. The challenge? Jupiter doesn't move evenly. It speeds up, slows down, and loops backward in retrograde. The Babylonians wanted to predict where it would be months in advance. And so they invented something extraordinary, a method to measure Jupiter's changing speed using the area under a trapezoid. Tablet BM 454 shows the calculation. A trapezoid with parallel sides representing Jupiter's slow and fast speed, and the base representing 60 days of motion. The area gave them the total distance Jupiter travels during that period. That's not a primitive trick. That's geometry-based integration. This was no small insight. The Greeks wouldn't develop similar geometric methods for another 1,400 years. It meant the Babylonians weren't just counting numbers. They were thinking abstractly about curves, shapes, and change. They used interval analysis to divide time, averages of rates to measure velocity, geometric areas to find distance, and algebraic shortcuts to simplify predictions. This shows a level of mathematical intuition historians never expected. But here's the mind-bending twist. They did all of this without equations, without letters, without algebra, and without the concept of a function. They saw motion as geometry in time. And it wasn't only astronomy. These methods influenced trade, taxation, and engineering across Mesopotamia. Their mathematics wasn't abstract philosophy, it was a tool, a powerful one. If Greece gave us proofs, Babylon gave us precision. Today, historians see Babylon not as a primitive world, but one of the first scientific civilizations. Their journals show decades-long data tables. Their calculations predicted planetary motion. Their geometry unlocked celestial secrets. And then, their knowledge vanished. When Babylon fell, so did its scientific tradition. For over 2,000 years, the world forgot their methods. Only now, with modern research and digital decoding, are we beginning to understand how advanced they truly were. The Babylonians weren't just keeping track of the sky, they were pioneering the mathematics of change. Long before Newton drew his first curve, the ancient Babylonians had already laid the groundwork. They didn't call it calculus. They didn't need to, because they understood something deeper, that the universe can be measured with shapes.